for my architecture diagram this time, I wanted to get a little bit more abstract about what I'm doing. And one thing that I spent a lot of time working on this last couple weeks is the data glob structure, which is what I'm calling it for now because it's a big glob of data. And what this does is it holds all the settings for the image processing, all the settings for the learner, all the paths for data, and any other knobs or values you might want to change when you're experimenting with this. And what this allows you to do is really abstract the inputs that are needed from the terminal or from a Jupyter notebook or from the GUI, even though I haven't finished creating a GUI yet. And the data glob structure allows you to use these methods to process the images, run the edge detections, and create the CNN model, which it also saves the location of and saves it as a file. It allows you to do these things without spending much time making complicated input statements and running big long commands from the terminal or from a Jupyter notebook to get these things up and running and get an output. And the output of the data glob structure at this point is a processed set of data created using the edge detections up here, a trained CNN model, which is a convolutional neural network model, confusion matrix and accuracy metrics. These are bits of information about how well the model performs and how accurate it is, and single image detections, which allow you to apply the model to further data in order to determine which label it matches. Alright, so now I'm going to do my software demo. So for step 1 here, we import the data glob data structure, which is right here. It's a regular Python file that includes all the methods and variables I'll be using. So we import that, we import operating system, and then step 2 is to create a data glob, and this will require an input path and an output path. And the input path is where the data comes from, and in this case I'm using a test set from the Kaggle program for artificial intelligence, and the out directory will just be my current working directory where this notebook is. So with that, we can create a data glob called plant glob, and then on step 3 we're going to adjust some knobs, set overwrite to true so that it can replace any existing data, and we're going to turn on Pruitt, K-Auto, and original, and then this command will let us see the configuration. So when I run that, we get back our glob config, and this tells us which algorithms are and aren't selected to be used. And the ones that are selected will be used here in step 4 when we run prepare database, which uses those settings to process the labels. And I'll skip through this a little bit because it takes a minute. And we've processed about 6,000 images under 2 different labels, and now we're ready to move on to step 5, which is to put these images in a data bunch, which is a data structure from FastAI. And we can do this, and then we have show data bunch, which shows us a couple sample images from our set from above. These are fully processed. And then we can move on to step 6, which is to create a model. After create model finishes, it will print a bunch of metrics relating to the model we just created. We can see that our accuracy was close to 90%. Training loss and valid loss both went down for each epoch, and error rate went down for each epoch, which is good. And if we look at the confusion matrix here, these were accurately predicted, these were accurately predicted, and these two were the incorrect predictions. And that's about it for my software demo. The last main phase of my project is to use this pipeline to generate a lot of results that I can compare.